Welcome to the YouTube channel of the ParisDeno meetup. My name is Denoemie. I'm the robot voice of ParisDeno. ParisDeno is the first French and Parisian meetup focusing on the Deno technology. The meetup is organized about every 2 months at the beginning of the month, and we usually plan the event 1 to 2 weeks before. The format can be regular or physical, like any classic meetup, but we also sometimes do an online format with a stream on YouTube. For more information, you can find us on the following social networks: LinkedIn, Discord, meetup.com, and of course, YouTube. You can also contact us directly on Twitter or at the email address contact@deno.paris. We will be happy to answer your questions. Of course, we are constantly looking for speakers. The proposed topics can be of any kind, such as, for example, personal or professional feedback, the presentation of a library or a framework, the use of Deno-specific features, and so on. The meetup and talks are inclusive, beginner-friendly, and if you've never had the opportunity to make your first presentation, you can still get started. It's even highly recommended. Don't hesitate. Apart from the classic 20 to 30-minute talks, the length and format can vary if you want, ranging from 5 minutes lightning talk to 1-hour workshop sessions. Finally, we have a GitHub repository where you can submit your abstracts. Even if my voice sounds emotionless, we would also like to warmly thank Paris TypeScript, our meetup partner. If you are interested in TypeScript beyond Deno, go to typescript.paris to find an active community on the subject. Sorry about my robotic presentation, but you prefer my accent, believe me. So, once again, on behalf of the ParisDeno team, welcome to the channel.
Hello guys, welcome for this new meetup. So tonight we have 2 talks. So the first one is made by Anthony. It's about the great organization, probably a quite rusty talk, maybe, we will see. And for the second talk, we have Bartek, and he will talk about Deno internal and all the architecture around Deno, all the updates around that. So if you have any question, you can use the hashtag question at the beginning of your sentence inside the chat on YouTube, and I will just ask each question at the end of each talk. So it's time to start. So Anthony, it's your turn.
All right. Bonjour, Patty. That is the extent of my French that you will get to hear. I am very happy to be here to talk with you all about Deno. Specifically, I'll be talking about Deno crate organization. And let me go ahead and share my screen. There we go. So as I said, my name is Anthony Campolo. If you want to find me online, you can find me at AJC Web Dev. That's for Twitter or for dev.to. It's also my GitHub handle. So anywhere where developers congregate, you can find me there. I want to give a shout out to Craig Morton. He's actually the one who retweeted this event and why I'm speaking here. And he's just really written a fantastic suite of articles about Deno over on dev.to. The left is that's just a selection of some of the stuff. He's written like twice as many articles as that. So really great stuff. I really highly recommend checking it out. But what is Deno? So Deno is an anagram. An anagram is a word, phrase, or name formed by rearranging the letters of another.
Question for you. Can you hear me?
Yes.
Yeah.
Can you hear me?
We are not seeing your slides.
You're not seeing my slides. Okay.
Yes. Classic issue.
Yep. Sure.
Someone on the chat was asking. Yeah.
Right. Yeah.
Yeah, it's good.
There we go. Right.
Yep, it's good. Thanks.
Cool. All right. Sorry about that. So Craig Morton, here is his information again. And then I was talking about Deno being an anagram. So an anagram is a word, phrase, or name formed by rearranging the letters of another, such as cinema formed from Iceman. So this is node, N-O-D-E, is changed around to Deno, D-E-N-O. And a lot of people wonder whether it's Deno or Deno. The story behind that is it was originally Deno because Ryan didn't really think about it too much and just called it Deno. And then at a certain point, we introduced a dinosaur creature as the the mascot. And then people were like, well, he's a dinosaur, so Deno the dinosaur, obviously. And then now everyone calls it Deno. So was Deno originally, became Deno. So this is why people will probably continue to argue about that forever. But what is actually Deno? So what Deno actually is it's a secure runtime for JavaScript and TypeScript. So this has to do with Node as it was originally structured. I highly recommend everyone check out a talk from Ryan Dhal. Here's a quote from it. JavaScript has changed quite a bit in the last 10 years since I originally sat down to do Node. So Ryan Dhal created Node. He's also the creator of Deno. And he gave a talk called 10 Things That He Regrets About Node. Now, I've watched this talk multiple times. For the life of me, I can only find 8 things that he regrets. If he wants to let me know what the other 2 are, I would love to know. I'm very curious. But here is kind of a selection of the things he regrets. And I really recommend you check out this talk because Node itself was actually launched with a talk. You can go back and watch Ryan's original talk about Node.js. And this is on YouTube, and it is from 2009. And I think that's really cool that you can have this project that is so massive. So many people use it. So many people depend on it. So many people have coded Node code. And at any point in time over the history of Node, anyone could have gone online and found like an hour-long talk of the creator of Node explaining exactly why he created this thing and exactly why he created it to be like this. I think it's really valuable, and we should take advantage of that resource. So I highly recommend everyone check out this talk. I think it's referenced probably more than it's actually watched, which is unfortunate. But it makes sense because it's very dense, it's a very technical talk, and that's kind of how it has to be to explain all the things he wants to explain. So the first point is not sticking with promises. Promises didn't exist when Node was created because JavaScript itself has evolved over the years, especially with ECMAScript. And since promises didn't exist, there were different implementations in different libraries that kind of competed with each other to become the promise implementation, and it diverged from Node. So part of making Deno is about being able to take now not only promises, but async await and bake all of that into the runtime. The next big point is security. So Node is not very secure, and you want to have a system be secure by default so that you have to give it permissions. It doesn't start with all permissions and then you give it permissions. You need to do it the other way around. Now, if you look at the rest of this list, it basically looks like everything that is involved with writing Node. You have package.json, you have index.js, you have your Node modules, and then the whole requires syntax. So we're really trying to take a lot of the basic fundamental pieces of Node and completely rewrite them and completely change how we think about Node. So this list of items will look fairly incomprehensible to anyone who hasn't written Node code. If you've written Node, then all this should look fairly familiar. But for people who maybe are fairly new to Node or haven't written much Node, you can kind of boil these down to 3 core points, which is Node is fundamentally divergent from the standardization of JavaScript since ES 2015. So we need to rewrite it because JavaScript itself is changed so much with all of these ECMAScript implementations. Node has too much access to the computer it's running on. So we need to have permissions. You have to explicitly give permissions instead of them being there from the start. And then the module/package system is a bit of a nightmare. And this is where a lot of the changes come into play in terms of how we want to break apart Node and how we want to make the different pieces available to import. So seeing all these problems, this is where you're standing in the rain at night, stoically facing the dark battle that is software engineering. So what do? We create Deno. Deno's principles are it needs to be secure by default, so no file, network, or environment access unless explicitly enabled. We want to support TypeScript out of the box. So TypeScript is a core component of anyone who wants to write Deno code. We want to ship only a single executable file. We want to have built-in utilities such as dependency inspector and code formatter. And we want to have a standard module system that is audited and guaranteed to work. And we have this at deno.land. What's kind of interesting is that a lot of the history of Deno is influenced by Go, even though it's written in Rust. So I'm going to be talking about how those two kind of forces have influenced where the code base is now and how it's gotten here. So back in 2015, this is when Ryan first started thinking about this project and thinking about the issues that he saw with Node and how he could possibly address them. And he was thinking of a project called V8 Worker, and it would be a binding to V8 with Go. So V8, for anyone who's not familiar, is the kind of core engine that is running JavaScript, both inside the browser and inside Node. So it was created by Google to be the JavaScript runtime inside of Chrome. And then Ryan extracted it and changed it so that it could work on the server. Now, we want to use V8 because it's just such an incredible piece of technology. And the question, though, is what do you use exactly to wrap it? So originally he wanted to use Go, and the idea was that you would have V8's APIs wouldn't be allowed to just create random JavaScript objects. So this is about the idea of permissions and how we can kind of lock the runtime down. So instead he wanted to do a message passing system that would pass messages between Go and V8. They decided not to do this because they were worried about the garbage collector. So Go has a garbage collector and Rust does not. So this is one of the core differences between the two languages, is that since Go has a garbage collector, JavaScript also has a garbage collector. So they're worried that they're going to have these two pieces get into conflict and that there'd be race conditions between the two garbage collectors. So by using Rust is more like C++. So while Node is a C++ runtime for JavaScript, Deno is a Rust runtime for JavaScript and TypeScript. So that's kind of how you can think about the differences between the two projects, what they're made of and what they're made to do. So why do we want to avoid monolithic design? This is a really core piece of how Deno is structured and how it's structured with crates. So we don't want a monolithic design because we want to be able to separate the concerns inside the CLI. Because Node is this one big monolithic project, it can be really hard to test different components of it and to kind of break it apart and have different teams work on it. So by having different pieces decomposed, you can test them independently and you can have more people working on the overall project by having them work on these subsystems that they can kind of own themselves. So this is why we want to have more of a decoupled design instead of a monolithic design. And this also gives us a principled binding layer for the CLI. And the other big thing is that we want to be able to use Deno as an embedded runtime in lots of different environments. So we don't just want to have a single monolithic server that's running on like EC2 that's always going to be on, is always going to be serving requests. We want to be able to do other things like maybe use it as a serverless runtime. For anyone who's not familiar with serverless, that's a term that refers to this new paradigm that was introduced by AWS Lambdas, which is kind of a function as a service idea, where instead of paying for a server to always be up and accepting requests, you just have these individual functions that respond to incoming events, such as a user clicking your page or trying to make a purchase or trying to upload an image. Any of those can be a function that is owned by a serverless runtime. And serverless runtime started with Node, actually, is that we wanted to just take all of this Node code we have and break it apart into small functions and just run those. So that's where AWS Lambda came from. And over the years, they've introduced other languages and other runtimes like Ruby or Python. And so Deno is really fascinating from a serverless perspective. And this is one of the reasons that I'm really interested in it in terms of how it can cross-pollinate with Redwood.js, which is a project that I've spent a lot of time working on. But I digress. The other big things is that you have something like databases doing MapReduce. So this is a classic kind of data science problem where you have a whole bunch of data and you want to break it apart onto different clusters and then do different operations on it. So by having an easily embeddable runtime, you could parallelize that task very easily. And then you also have GUI applications like Electron. Electron is also built on Chromium. So all of these kind of projects, they're all using similar tech. And so Deno is aiming at a lot of these similar use cases. So a Rust crate. A Rust crate is like a Ruby gem or a package on NPM. All it is a way to just take a bunch of code and package it together in a way that makes it easily shareable and distributable so that other people can use your code and that you can get your code on the internet very easily. So a Rust crate is how Deno is organized. It's organized into individual Rust crates. So we have kind of the four main Rust crates. There's actually, as I was looking on kind of Ryan's like crate profile, there's actually a whole lot more stuff than this, but this is kind of the main pieces. And this is based on a talk Ryan gave for Deno Israel a couple months ago. And all of this is kind of, in motion. And that's partly what the next talk will be about, is kind of like, what is the state and where is, all of this going. But as of now, this is a fairly good way to look at the overall project, and you can go to any of these crates just online and find these and kind of inspect them and take a look at them. So we've got the main Deno executable. So that's like the main thing that most people are going to be using when they're going to be downloading this and using Deno. Then there is the Deno TypeScript package. So this is for type checking and type stripping at compile time. For anyone who hasn't used TypeScript, the idea of TypeScript is that you add types to your JavaScript code. So types being, if you have a string versus a number, you will explicitly say whether it is a string or a number. And that's what puts types onto your JavaScript. And this enables lots of extra tooling in terms like autocomplete and things like that. But what happens is all the types are run through a compiler and stripped out, and you get JavaScript code at the end. So even though you write in TypeScript, what the compiler spits out is just regular JavaScript. So that's what the type checking and type stripping is. We also have the Deno core package, and this is what contains the ops and the resources, which are kind of Deno concepts that we'll talk about later as we get into that. And then there's the Rusty V8 crate, which is the bindings between V8 and Rust. So V8 being the kind of runtime, and then Rust being what we use to talk to V8. So we'll start with Rusty V8 because this one's kind of the most complicated and has the most going on. So V8 itself is just an absolutely massive C++ library. It has about 800,000 lines of code. So it's very complex. And Rusty V8 is a framework that adds bindings to it. So this is so you can write your Rust code instead of having to write C++ code. So this gives you an interface between Rust and V8, and it provides kind of safe bindings because V8 itself has a lot of security baked into it. It's sandboxed. It's because the browser is one of the most hostile environments in all of computing. There's been a ton of work put into that. So this is trying to leverage all of that security work that's gone into V8. And then you can also recompile it with different compilation settings. So if we look into each of these a little more, so the zero cost interface means that the objects can be manipulated in Rust exactly the way the objects are manipulated in C++. So there's a guarantee of exactly what you're getting at, what you're putting in. And then the type system is basically what forces the safety, because Rust is based on functional paradigm, even though it's not really thought of as a functional language, it's thought of as more of a systems language. It is actually typed like, I think it's the ML family. I may be wrong about that, but I'm pretty sure that's what it is. And so that's why it's very useful to enforce typing. And then with recompiling, you have pre-built binaries that can be created through GitHub Actions. And so this is really interesting because GitHub Actions is a somewhat newer piece of GitHub that can be used for continuous integration, CI. And so this is creating a kind of deeper integration with your workflow. And then you have the V8 source code is distributed inside the crate file itself. So now let's talk about Deno core. So the Deno core is meant to address problems with Node, as we talked about at the beginning of the talk with Ryan's regrets about Node. So there was no centralized binding interface in Node. So this made it really hard to get like global metrics and monitor and do security checks and just kind of like understand the whole state of your Node thing, like what's it doing. And this led to lots of problems with big companies like Walmart, who would start having their Node blowing up, and then they didn't really know how to inspect it, so they had to introduce these other tools that could actually like look into Node and get you stack traces. So this led to a lot of problems, and you'd have callbacks issued from C++ without being requested, and you'd give users the opportunity to create code without any back pressure, which is an issue. So with Deno, they introduced native bindings through this idea called ops. So ops are just native functions called from JavaScript, and everything in the core executable is built on ops. And since it's all built on the single abstraction, they can optimize it and they can get better performance. So you have just a single executable binary. So this is really nice because then you can use array buffers as your parameters and return values, which are basically like a generic fixed length raw binary data buffer. So a lot of this is just based around like knowing exactly what you're putting in and what you're getting out and being able to inspect it really easily. And with the array buffers, then you can pass pointers back and forth between JS and Rust, and it's really easy to know like what you're doing with those pointers. And then it's also integrated with the event loop. Deno uses Rust's event loop called Tokyo, which I don't know a whole lot about, but sounds super interesting. So you should look into that if you're curious about that. And in op, it will either complete synchronously with a result, or it'll return a promise corresponding to a Rust future. And so Rust futures are used for async data. And so if you're interested in any of the async stuff that's going on, that's another kind of big feature that could be like a whole talk in itself. So we had ops, and then we also had resources. These are kind of the core ideas that we're building on in Deno. So it's a lot like a file descriptor in POSIX, which is like a specification for operating systems in C. So something like Linux, and it's an integer identifier given to JavaScript to reference an object allocated in Rust. So if you look over on the right, that's kind of a diagram to show how the Rust and V8 bindings work. And this was from Ryan's talk in May. So I'm not sure how accurate this still is, but that's where this originally came from. And then, yeah. So now we also have Deno. So Deno itself, as I said, is the main thing you're going to be interacting with. And I find it hilarious that this is the entire crate page. This provides the actual Deno executable and the user-facing APIs. The Deno crate uses the Deno core to provide the executable. And there you go. If you click the repository, this will take you to their main GitHub, which has a lot more information. But this is kind of the whole shebang when it comes to Deno. This is the main thing you'll be using. And so this is what hit version 1.0 months ago, and kind of when everything blew up and a lot of people were talking about it, and we're now in the 1.4.x range. All right, so the goals of the main Deno is to just have a single executable, and we want to provide secure defaults. So a lot of this is stuff that we've been talking about throughout the course of the talk. And then we also want to be browser compatible. So the idea is using things like ES modules. So we have changes in the language, not just for promises and async, but also for the module system itself. Node originally used CommonJS, which used the require syntax. It was different from the require modules. So a lot of confusion there, and everyone's now centralizing around ES modules. And then all of this gives you then better built-in tooling for unit testing and code formatting and linting. And then they want to not leak any V8 concepts into user land. So separating out Rusty V8 from Deno core executable helps a lot with that. And then they want to be able to serve HTTP efficiently. And then finally, we have the Deno TypeScript. So this one is kind of a work in progress. It's where the compiler is incorporated, and the compiler was causing performance issues. So they've had to kind of strip away most of the TypeScript compiler and move that stuff into Rust. So this should not be used in production. And if you're interested in this, you can talk to the core team, you can send some messages, and then kind of let you know the state of this. But this is still a work in progress. And yeah, that's the whole talk. So thank you for listening.
Okay, thanks, Anthony. Great talk, was super clear. I didn't see any question on the chat. Maybe we will wait a couple of seconds just in case, because we have a delay because of the stream.
Sure, yeah. Feel free to send me messages on Twitter if you're curious about anything. I'm always open to talk.
And at the beginning of your talk, you are saying that you're talking about serverless things, and I don't know if you know the Andy Hayden. He creates a lot of things around that, especially for AWS. So you have the support of serverless and DynamoDB, if I remember. And if I remember, if I'm right, there is also someone at Microsoft who implement Deno for Azure functions, if I remember.
Cool. Yeah, I'm very interested in different deploy targets for it, and it's a really cool space to get into right now.
But I don't know for GCP. I don't know if they've done anything for that.
They'll get there eventually. Someone will do it.
Okay, so it seems we don't have questions, so maybe we can just pass the mic to Bartek for the second talk. Thank you, Anthony.
Thank you.
Hello, everyone. Thanks for having me here today. I'm gonna be talking about some of the Deno internals. As it turns out, a lot of this stuff has already been described by Anthony before my talk, which I think is really, really good because, well, I'm gonna focus on some more complex stuff. So yeah, let's get right into it. So shortly, what's the goal of this talk? I want to give you a high-level overview of the Deno binary, the Deno CLI, so this thing that you download to run your code. I would like to describe some of the most significant parts of the runtime, and well, I don't have to explain it anymore why Deno is not a monolith, but I will go a bit more in depth why that's the case. So let's start with maybe something a bit controversial. So Deno presents itself as a runtime for JavaScript and TypeScript. However, I feel that calling it JavaScript TypeScript toolchain is a bit more concrete, as not only can we run our code, we got a plethora of other tools built into the binary itself. So, well, if you want to run code, you use the runtime itself, and you do that using Deno run or Deno repo. You can bundle your code using built-in bundler. We've got a dependency inspector, we've got a documentation generator, formatter, linter, test runner, and whatnot. So a bit of history first. The first commit of Deno was made on May 13th, 2018. And I linked to Ryan's talk about it. 2.0 happened on May 13th, 2020, which is not a coincidence. We thought it's gonna be cute to release it exactly 2 years later. So yeah, move fast and break things. This is kinda what we're doing right now. So 1.0 was released in May, and we're already at 1.4.4 as of last Sunday, but it will change on Friday. So we release on weekly basis and the patch releases. So we try to fix bugs as they come in and release often. We do minor releases every month, or rather I should say we did release every month. Now we're switching to 6-week cadence, and minor release as well to be determined. There is no plan for 2.0 yet. Maybe there is, maybe there is not. Can't confirm, can't deny. So yeah, let's jump into the actual architecture. Deno is not a monolith that we already know. Instead, it's a collection of Rust crates. Cool, what does it mean actually? So here's my a bit clunky scheme of how the Deno binary itself looks, and I'll try to walk you through each of the pieces one by one. So the main runtime, the thing that actually runs your code, consists mainly on 4 pieces. The actual JavaScript engine, so V8, and layers that are built on top of V8 to actually make it usable from Rust. An event loop, in case of Deno, it's Tokyo. In case of Node, it's UVlib. A TypeScript compiler, and we used actually TSC, so the TS compiler you have in Node, but it's not implemented in Node, which I'll describe shortly. And we have this one big bug that I just called module graph, which is a system for code caching and analysis. So let's start with the most essential part, so the runtime itself, the engine. As we already know, Deno runs on V8, which is a JavaScript engine used in Chrome, Chromium, and all the related projects. Super fast, super optimized, super complex. And Deno is very tightly integrated with V8. It's not that we can switch out to some other engine easily. In the early days of Deno, we did not have this crate called Rusty V8, which Anthony told you that it's a layer of bindings from V8 to Rust. We had something called libdeno, and essentially it was a collection of a few files that was a foreign function interface between Rust and C++. It worked, it got us a very long way. However, it was very hard to maintain and reason about this code. And the boundary where we go from V8 to Rust and back again was very not clear. So that's how Rusty V8 came to life. I'm not gonna go into details about Rusty V8 because Anthony already did that. Suffice to say, it's just a Rust crate that does this function for foreign function interface with C++, but exposes you with purely Rust interface for end users. And we use this Rusty V8 crate in Deno core. Deno core is also a low-level crate. However, it's a bit higher level than Rusty V8. So you don't have to interact with V8 directly when you use Deno core. Instead, we provide you with a few abstractions that make your life easier. One of the abstractions that was already mentioned today is ops and resources. So this is the mechanism that allows you to call Rust function from JS and provide some native bindings like file reading or opening a NetSocket. And the rest of Deno core is basically infrastructure around it. So we provide a single structure called JS runtime, which hopefully is self-explanatory. It gives you a single instance of V8 isolate, so the actual thing that executes your JavaScript code, and wraps it in Rust APIs that allow you to do some things like module loading. So ES module loading is quite different from using common JS. ES modules in nature, especially with top-level await, are fully asynchronous. So loading and execution is done asynchronously. And it's very not trivial to connect all the dots from V8 to expose you an interface that allows you to load this stuff asynchronously. And one thing to keep in mind in case of Deno core is it has no idea of TypeScript or any other fancy tools. It's bare bones JS runtime that if you want to use, you're gonna have to get your hands dirty. Let's go over to the module graph and module caching, because before we can execute anything, we first need to obtain the source code for it. So module graph is a piece of logic in Deno that is responsible for collecting the whole tree of dependencies that the module you want to execute depends on. So if we start with a single entry point, like you can see on the screenshot in the corner, the module graph will take it and perform some actions to collect everything you need to actually execute this code, which is fetching the source, parsing it, figuring out what are the imports or re-export in that file, obtaining those, and repeating until you got everything. So once you analyze all your files and see that there are no new imports, you can start assembling those files in this graph structure. And important part in case of Deno is that it can execute code from the internet directly. You don't need to install it. So it'd be very silly if you had to download the code over and over again on each run. And well, Deno doesn't do that. Instead, the code is cached on your machine, similar to node modules, but node modules are per project. So everywhere you have a package JSON, you will have node modules. Obviously, unless you configure to use some kind of PNP or shared folder. But in Deno, this cache is global for your machine. So if different projects use the same sources, they can use the same cache, which, well, is just less stuff to download from the internet. And the important part is that not only do we cache the sources that we obtain from the internet, we also cache sources that are transpiled. So Deno is TypeScript runtime. But obviously, you cannot execute TypeScript directly. It first has to be transpiled to JavaScript. And in Node, what you do is you set up your build pipeline to transpile your sources from TS to JS. And in Deno, this is all done automatically for you. So your experience is pretty pristine. You just run your TS file and all the magic happens behind the scenes. Okay, so let's talk about TypeScript in a bit more detail. So, well, TypeScript is awesome. Let that be said. But there are some problems with it as well, or at least hoops that we had to get through. Deno has a custom implementation of TypeScript compiler host. So when you download TypeScript.js, this huge file that is like almost 10 megabytes, you get all the infrastructure that is needed for you to build your custom host. So if you've ever seen LSP or TypeScript plugin, then probably those plugins implement their own hosts as well. And in case of Deno, since we already talked about JS runtime that is provided in Deno core, it's no surprise that Deno's TypeScript is actually implemented using this JS runtime. So basically, we get this huge TypeScript source code and run it directly in V8. However, there are some problems with this approach. The first one is, since this TypeScript JS is so big, it's also pretty slow to execute. So if we were to parse, compile, and execute the same code over and over again, every time we invoke TS compiler, it'd be just dead slow. So one of the solutions to this problem that is incorporated into Deno is using V8 snapshots. So the V8 engine provides an ability for you to execute some JS code and then snapshot it, which means V8 just takes a chunk of heap allocated to the runtime you're running in, and it serializes it into a binary format. And we use this technique to take the snapshot of TS compiler and write it down into the final binary. So then when we invoke TS compiler, we don't have to go through this whole parsing, compile, execute process. We just smash this serialized memory back into V8 and we're up and running. And by the way, you can check the time it takes to invoke TS compiler in Deno on our benchmarks page. So we do keep track of it. The other problem with TSC is its API is fully synchronous, and this caused us many headaches along the way. Mainly, if you want to execute TS code, you first need to transpile it. And the problem with that was, since TS APIs are synchronous, we'd have to block every time we want to obtain new source code. So TSC would first parse your file, check out for import-export statements, give them back to you, and then you'd have to fetch them and feed them into the compiler again. And since it's synchronous, it's like no-go if you want to download files from the internet. So what we did first was use some of the synchronous TS APIs and hacked it together with some Rust magic to have sorta kinda asynchronous dependency analysis. However, the whole setup was extremely cumbersome and error-prone, so we had to look for a better solution. And we'll get into that solution in just a moment. So in the early days of Deno, say a year ago, for example, Deno was very tightly integrated with TSC as well. So we used it not only for type checking, which is like the main use case for us, but we also leveraged it for bundling and transpiling sources. However, again, TSC is quite slow. Parsing the files, emitting code generation, it's just slower than in Rust. So what we did is we went on looking for some way to move all of this stuff into Rust, and we found SWC. And this SWC project has been a game changer for us and allowed us to move more and more of our infrastructure from JS into Rust. So let's look at this SWC thing. So SWC is Speedy Web Compiler, at least that's how it introduces itself. It's super fast JavaScript and TypeScript compiler. And yeah, why do we use it? So first thing, it's crazy fast. It's an order of magnitude faster than, for example, Babel or TypeScript. And secondly, it's written in Rust, and our general consensus is that if something becomes hard, slow, or cumbersome to do in JS, just move it to Rust. And that's exactly what we did. We introduced SWC to our code base and started using it for something super simple, which was taking out the dependency analysis out of TS and putting it in Rust. So instead of feeding source files one by one into TypeScript and obtaining them as we go, we opted into full upfront analysis and then feeding all the sources to TypeScript in one go. And nowadays, SWC is used for doing a lot of heavy lifting in Deno. The heaviest task is obviously this dependency analysis, but we're going into the direction where all transpilation or compilation of your sources happens in Rust, and TS is used only for type checking of your source code. Yeah, moving on. Let's take a look at dprint. So Deno has built-in code formatter. If you type Deno fmt, well, it's just gonna format your whole current directory, or maybe not whole current directory, but rather JS and TS files in the directory. So Deno fmt started originally as a prettier formatter. So we had this subcommand, but underneath it just downloaded bundled prettier and run it on your code base. The problem was, well, exactly the same as with TSC. It was slow. And besides that, it was kind of silly to provide a subcommand in the binary and then require user to download more code just to be able to run it. So dprint came along, and dprint is basically a drop-in replacement from prettier. So if you use prettier today, you can just switch to dprint and it should work exactly the same, just faster, a lot faster. And well, the other advantage is also that it's written in Rust, so integrating it into Deno was just a breeze. And the experience with dprint is just phenomenal. You type Deno FNT, and it's done before you lift your finger from Enter key. Yeah, so there was a, say, minor downside with this approach, which was prettier was configurable. Like, you could tweak all kinds of knobs and switches, and dprint allows you to do the same. However, in Deno, we opted to just have an opinionated configuration for this formatter, and we don't give a way to customize it. So it's probably one of those holy wars if you should config it or not, but I think it's similar to Go FMT. It's no one's favorite, but everyone uses it and everyone's happy. And that's the direction that Deno FMT is going to. Okay, moving on. Let's take a quick look at Deno lint. So Deno provides also lint subcommand, which runs some static analysis on your code and shows you common problems, much like ESLint. And the initial idea for implementation of this functionality was the same as with format. So take ESLint, bundle it for browser, and then run it inside Deno. However, we actually never got to the place where we bundled it and were able to run ESLint. And also, well, ESLint is also slow. So it takes like a second or 2 seconds just to run it. So we decided to just write our own code linter. And I have to warn you, it's still work in progress. That's why it's hidden behind unstable flag, but it's working. And we got recommended rules from both ESLint and ESLint TypeScript implemented in it. So you can just run Deno lint -- unstable, and it's similar to formatter in that it's very fast. It's also orders of magnitude faster than ESLint. And well, again, here, no config. We're pretty opinionated about it. And let's also visit Denodoc, which is our documentation generator. So Denodoc is yet another Rust crate that is not part of Deno itself. It's like a separate project. You can go and work only on that project. And by the way, you can use it in your other projects, or you can compile it to WASM and run it from Node. And its purpose is simple. Just parse out the file and show me JS-doc that is defined in this file. So we provide 2 ways to see this documentation. One is to just see it in your terminal, and the other is a nice web interface that consumes the output from Denodoc, but presents it in in a web interface. And by the way, you can also just write your own interface, and one of contributors did and made like an offline version that you can run directly from your desktop. So yeah, there are a lot of more parts in the Deno binary itself, but for one, we don't have that much time to go into all of them. And the other is they get even more complex than what we visited in this short talk till now. But I wanted to give you an idea. Why are those tools written in such a way that they are not actually part of Deno? You have to like work on a separate library just to use it in Deno later. And the reason is, well, again, what Anthony said in his talk, you just encapsulate this complexity in a separate libraries and draw a clear boundaries between those interfaces. So implementation of linter or formatter or doc generator in Deno executable is like 50 to 80 lines each because we just consume outside crates. And what's great about this approach is that you can scope your interest. If you're interested in Deno, for example, in doc generation, you don't have to learn the whole Deno thing, how to build it, how to debug it locally. You can just focus on a single repository called, in this example, Deno doc, which is way simpler to develop and to contribute to than Deno itself. And the whole idea with our recent works, starting from 1.0, is to factor out as many parts of the runtime into separate crates or separate libraries. So, for example, in Deno, we got this browser compatibility thing. So you got quite a lot of APIs that are available in the browser that are available in Deno itself. For example, text encoder or text decoder. And we managed to pull out all of those APIs into a separate crate. And then we have an implementation of fetch API, which also is a separate crate. And we plan to extract more and more functionality. So think about all the APIs available on the Deno namespace that are going to be separate crates as well. So one can imagine a future where I need Deno, but not all parts of it. So I'm just going to grab like web APIs and I just need to access network. So I'm going to grab Deno networking crate and compile your own runtime just with those two parts. However, this is obviously for the most advanced users. Most of the time, you don't want to compile your own JS runtime. But if you do, there is a way to do that, which is, well, it's not painful, but it's also not a breeze right now. So yeah, stay tuned. We're going to be working towards that. And one more thing that I wanted to talk about is actually contributing to Deno. So all of this infrastructure and how it's built, it's overwhelming and it's hard to get in. But if you want to do that, don't be discouraged. Just come by to our GitHub or our Discord and try to contribute. There's been a ton of new people that started contributing after 1.0 was released. And the general feeling I get from them is that it's not that hard to start contributing to Deno because it's written in Rust. A lot of the stuff just makes sense if you look at it. I mean, of course, you might be fighting borrow checker or some other Rust quirks for some time, but in general, you can dive into some kind of module and get idea what it's doing without much trouble. And by the way, it's not only Rust. We've got a ton of JS code, and we've got even more of TS code. The whole standard library that we provide is written in TypeScript. So if you were thinking about contributing to Deno, but didn't get to it, please do drop by our Discord or drop by our GitHub, and yeah, let's see what we can do together. Yeah, thank you. A bit fast, but hopefully I talked about some of the interesting bits that are not so obvious when you look on the Deno itself. So if you want to message me or talk about some project, just drop me an email or something, and I'll be happy to take your questions if there are any.
Okay, Bartek, thanks for this great talk. So tonight, two great talk. Thank you for that. So currently we don't have questions. Yep, sorry.
Thank you for having me.
You're welcome. It's a pleasure.
Always a pleasure.
It's our pleasure. And so currently we don't have question. Let's wait a couple of seconds, and we will see.
Yeah, if you're too shy to ask in chat, just drop me a message or an email.
Yeah. It seems people are shy tonight. No questions.
Yeah, not that much people, sadly.
No. So we don't have other question.
Okay.
Okay, so if nobody has question, we're gonna end the meetup. So Anthony and Bartek, thank you very much. Really two great talks. So
yes,
thank you for that. Lilian, if you want to say something.
Yes, thank you. That was very nice. And as always, the meetup is recorded. So if anyone who's not there want to see that, you can use it. You can use it to share it with some people for your talk. No problem for that. So yeah. Again, thank you everyone. And the next meetup will be in 2 months. So I hope we can do that in a physical way, but I think so. So I think the next meetup will be online, also.
Yep, maybe in December.
Yeah, maybe in December, in the beginning of December.
Okay, thank you, everybody.
Thank you.
See you.
Thank
you.
you.
Bye, everyone.